Welcome to Notes Activity Lesson 1-3, More Properties of Exponents. So today we're going to develop the power of a power and the power of a product and the power of a quotient property. And we're going to simplify expressions involving exponents. So let's review some of those properties that we know. So the division property says that if we have the same base and we're dividing, that we will subtract the exponents. And the product property says that if we have the same base and we are multiplying, then we can add the exponents. And then we had the negative power property, which says that if we have a to the negative m, this is equal to 1 over a to the m. And then the zero power property. And the zero power property says that if we have any value a raised to the 0, this will be 1, except that a cannot equal 0. Oh, and also for the division property, a cannot equal 0. And also for this one, a cannot equal 0, right? We can't have a 0 in the denominator. All right. So it says write each expression in expanded form. Then write the expression using a single exponent with the given base. The first one has been done for you. And so they've said, oh, we have 2 to the second to the fourth power. So what that means is that we have 1, 2, 3, 4, 2 to the seconds. And then we can expand that further because each 2 to the second is 2 2's and 2 more and 2 more and 2 more. And so altogether we would have 2 to the 8th power. All right, 5 to the 5th, this is going to take up quite a bit of room. So 5 to the 5th to the third power would be 5 to the 5th 3 times. And then expanding that out, we would have 5 5's here. So 1, 2, 3, 4, 5. 5 more 5's here. 1, 2, 3, 4, 5. And 5 more 5's here. 1, 2, I'm going to come down here. 3, 4, 5. So all together I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This would be 5 to the 15th power. And then I have x to the third 4 times, which means I have x to the third, x to the third, x to the third, and x to the third. And then each of these x to the thirds has 3 x's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be x to the 12th power. Okay, based on the pattern you observed in item 1, write the missing exponent in the box below to compute the power of a power property. So this is a big one. We're going to use it a lot. What relationship do you notice between this 2 and 4 and this 8? Or this 5 and 3 and this 15? Or this 3 and 4 and this 12? If you said that you're multiplying these, you're correct. This is m times n. All right, use the power of a power property to write, so I'm going to write that down over here, the power of a power property, right? The power of a power prop, which is a to the m to the n power is equal to a to the m times n. So there's our new rule. All right, use that property to write this is a single power. So we have x, I'm going to do it off to the side because there's not a lot of room right here. So we have x to the 6 over 5 all to the 25th power, which is x to the 6 over 5 times 25 over 1. And then you can either reduce the cross cancel, right? Or you can just multiply straight across. I am going to cross cancel to get rid of this. So that's 5 goes into itself once and 5 goes into 25 5 times. So I have x to the 6 times 5, which is x to the 30th power. So x to the 30th. It says write each expression in expanded form, then group like terms. The first, then write each expression as a product of powers. The first one has been done for you. So we've got 2x times 2x times 2x times 2x, right? 2x to the fourth. And so that would be 2 times 2 times 2 times 2, which is 2 to the fourth. And then x times x times x times x, which is x to the fourth. All right, let's try one on our own. So we've got negative 4a to the third power, which would be negative 4a times negative 4a times negative 4a, which would be negative 4 times negative 4 times negative 4 times a times a times a, which would be negative 4 to the third power. Now, when you have a negative, it's important that you put parentheses around that, and then a to the third power. And then finally, we have x to the third y squared times x to the third y squared times x to the third y squared times x to the third y squared, which would be x to the third times 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 y squared times y squared times y squared times y squared, which would be x to the, this would be 12th power, x, or actually you could rewrite it. I guess we'll do it in 2 steps. This would be x to the third to the fourth power, and this would be y to the second to the fourth power, which we can apply this rule. That means it would be x to the 12th power, y to the 8th power. So you can leave it either way, but this is going a little bit further. Okay. So let's turn it over to the next page. This is based on the observations or the pattern you observed in item 4. Write the missing exponents in the boxes below to compute the power of a product property. So the power of a product property, power of a product. So meaning when we're multiplying, right, and we're raising, so we're multiplying inside, right, and we're raising both items to the same exponent, do you notice that each of these got raised to the fourth power? And that each of these got raised to the third power? And that each of these got raised to the fourth power? And then we could use the previous rule to simplify. And so that rule is a b to the m power equals a to the m b to the m. So again, a b to the m power means a to the m b to the m. All right, next, it says to use the power of a product property and the power of a power property to write each expression as a product of powers. All right, so we're going to distribute this, right? Not distribute, we're going to use the power of a product rule and multiply both of our exponents, raise both of our exponents, right, to the 8th power, so we are going to multiply them. So off to the side, this will be a. So I have c to the 1/2 times 8 over 1, and I have d to the 1/4 times 8 over 1. And then I can simplify. That's c to the 8 over 2, d to the 8 over 4, which is c to the 4th, d to the 2nd. So c to the 4th, d to the 2nd. B, we have m to the 12th times 3/4, so I will make this a fraction, and n to the 20th times 3/4. And I will simplify. 4 goes into itself and into 12. So 4 goes in there once, 4 goes in there 3 times. So that's m to the 3 times 3. N to the 4 goes into this once, 4 goes into that 5 times. That's n to the 5 times 3, which is m to the 9th, n to the 15th. So m to the 9th, n to the 15th. Okay. So now we're going to make use of structure. It says use the patterns you've seen to predict and write the missing exponents in the boxes below to complete the power of a quotient property. So the power of a quotient property, if we apply this same idea, right, I would think that we're going to have to raise both a and b to the m power, and that is the power of a quotient property. So I'll write that off to the side here. The power of a quotient, or the power of a division property, I like to use division, is if we have something like a over b all to the m power, this is going to be a to the m over b to the m. Okay, so this is another big rule that we'll be using. This is we have now, I believe it's 4 plus, so we have 1, 2, 3, 4, 5, 6, 7 rules now that we have to keep straight. All right, so we're going to use this property. So that means I'm going to have to raise or multiply each of my exponents by 1/3. So I'll have x to the 3 times 1/3 over y to the 6 times 1/3. I'm going to stop putting my numbers under there. I can just see those cancel. That's x to the first. And I can just see that that reduces to a 2. That's y squared. And so then I wouldn't leave the x to the first. I usually drop that first degree and just rewrite it as x squared y squared. And similarly, I've got p to the 3/4 times 24 over q to the 5/6 times 24. And I see that these are going to reduce. 4 goes in there once and in there 6 times. And 6 goes in there once and in there 4 times. So this is going to be p to the 3 times 6 and q to the 5 times 4, which is p to the 18th, q to the 20th. All right. We're going to pause right there so this video does not get too lengthy. It's difficult to upload. Oh no, we're only at 12 minutes. Never mind, we're good. Okay. All right, so simplify this expression and write it without negative powers. So I'm going to do it off to the side. We have 2x to the second, y to the 5th, and then all cubed, and 3x to the second, all to the negative 2 power. Okay, so there's lots of ways you can begin. Some students like to expand this out. So if you could picture me writing this 3 times, I would have 2 times 2 times 2, x squared times x squared times x squared, and y to the 5th times y to the 5th times y to the 5th. Now, if you want to do it that way, you can. I might do that on a separate sheet of paper. I haven't decided yet. But I'm going to instead use the rule that says it's the power of a product rule, right, where I'm going to multiply each of my exponents by whatever power that is. So I'm going to multiply, this is 2 to the 1 times 3, x to the 2 times 3, and y to the 5 times 3. I'll do the same thing here. That's going to be 3 to the 1 times negative 2 and x to the 2 times negative 2. All right, then I will simplify my exponents. That's 2 to the 3rd, x to the 6th, y to the 15th, 3 to the negative 2, and x to the negative 4. Now, it does say to write them without any negative powers. And so to write them without any negative powers means that I would need to drop these into the denominator. So I would have 2 to the 3rd, x to the 6th, y to the 15th, over 3 to the 2nd, x to the 4th. And now that I have this happening here, right, I can go ahead and group my coefficients, which is 2 to the 3rd over 3 to the 2nd. And then I have x to the 6th over x to the 4th. And then y to the 15th has nothing. It doesn't belong to anything. All right, so then I would use the subtraction rule right here. These are not the same base, so you cannot use the subtraction rule. This is just going to be 8 over 9. I'll use the subtraction rule. That'd be 6 minus 4, and then y to the 15th. So this would be 8x to the 2nd, y to the 15th, and the only thing in the denominator would be this 9. Oh, that's what they had. Okay, now you can do some of those steps in other orders. For example, right here, I could have just added my exponents. I could have said 6 minus 4 and gotten my x squared. That's fine. But what you can't do is apply the rules in the wrong way. The order that you apply them in generally doesn't matter. The only one that really does matter is this rule, the power of a product rule, or sorry, the power to a power rule. That's right here. This rule should come first before you do any of the others. And the other rules can go in whatever order you'd like, right? But this rule should be always the first one applied. Okay. All right, let's flip it over and take a look at the back. And it says example B. So they're just giving us a ton of examples to try this new property. So I'm going to do this off to the side. We've got x squared y to the negative 3 over z. And this whole amount is being raised to the second power. And so this is the power, the power of division rule, right, where we're going to raise everything to this power. So we'll have x to the 2 times 2, y to the negative 3 times 2, and then z to the 1 times 2. And then we'll simplify our exponents. That's x to the 4th, y to the negative 6, and z to the 2nd. And then all we have to do is take care of this negative exponent. We cannot leave it. And so this negative exponent means that this is going to drop into the denominator, and we'll get x to the 4th over y to the 6 z squared. All right, let's take a look at the next one. Sorry, I had to get a drink of water. All right, so the next one is a try these. So I'm going to try this one with you. I'm going to try all of these with you, and then we'll probably pause at that point because the video will be getting kind of lengthy. So let's go ahead and rewrite this. We're going to make sure that we distribute that 3 to each of these exponents. So we've got 2 to the 1 times 3, x to the 2 times 3, y to the 1 times 3, times, I have negative 3 to the 1 times 2. Now remember, when I have a negative, I always put, when I have a negative coefficient, I always put parentheses around it. And then x to the 1 times 2, y to the 3 times 2. Okay, so that's going to be 2 to the 3rd, x to the 6th, y to the 3rd. And then this would be negative 3 to the 2nd, x to the 2nd, y to the 6th. And now we're multiplying, so I'll group like things. So I'm going to bring these 2 to the 3rd and the negative 3 to the 2nd out together. And then I've got x to the 6th times x to the 2nd. And I have y to the 3rd times y to the 6th. Now there's no more power to the power rules. We're just simply multiplying these. So when I multiply these, this is going to be 8. This is going to be 9. Negative 3 squared is 9. That's why it's important you put the parentheses. This is x to the 6 plus 2. This is y to the 3 plus 6. 8 times 9 is 72. And this is x to the 8th, y to the 9th. All right, let's try the next one. I think I'm going to be running out of room here shortly, but I'll try to squeeze as much as possible on here. Negative 2ab, and then we have 5b squared c all to the 3rd power. Now, common error is that students want to distribute this negative 3 to these two items, or these items over here. Remember, only what's in the parentheses, only this portion is being raised to that 3rd power. So we have negative 2ab, and then times 5 to the 1 times 3, b to the 2 times 3, and c to the 1 times 3. I'm going to start rearranging things as I go. Negative 2 times 5 to the, that's 3rd. And then I have an a, I have a b to the 1st, I have a b to the 6th, and I have a c to the 3rd. All right, that would be negative 2 times 5 to the 3rd power would be 5 times 5 times 5, which is 125. A, b to the 1 plus 6, and then c to the 3rd. And then finally, that's negative 250, a, b to the 7th, c to the 3rd. All right, I'm going to move to a separate sheet of paper because as you can see, I'm running out of room. So moving on to another sheet of paper. For C, I have 4x over y cubed, and this is all being raised to the negative 2 power. So that means I have negative 4 to the 1 times negative 2. I have x to the 1 times negative 2, and y to the 3 times negative 2. Okay, so that would be 4 to the negative 2, x to the negative 2, y to the negative 6. Now, this is almost simplified, but we have to, because these are all negative exponents, that means that these two, to become positive, will need to move into the denominator. So we'll have a 4 to the positive 2, x to the positive 2. Common errors, students will move things but leave the exponent a negative. Remember that the rule we're using is that a to the negative m equals 1 over a to the m, right? It becomes positive. And similarly, that means that this is going to move up to the numerator to become positive. So that's y to the 6th. And then finally, we're going to simplify that. That's y to the 6th over 4 squared is 16, and then x squared. All right, let's keep going. We have 2 more to do. So D is 5x over y all squared, and y cubed over 10x squared. No exponent here. So let's go ahead and make sure we multiply everything inside of here by 5. All the exponents are being multiplied. So 5 to the 1 times 2, x to the 1 times 2, and y to the 1 times 2. And then we have y to the 3rd and 10x squared. Okay, so this is 5 squared, x squared over y squared, times y cubed over 10x squared. Now we can write this all in one fraction if we'd like, or you could skip that step, it's up to you. I'm going to go ahead and write it all in one fraction, 5 squared, x squared, y cubed, all over 10x squared, y squared. And now I can begin using the subtraction property. 5 squared is 25, so we're going to have 25 over 10 times, this is going to be x to the 2nd minus 2, and y to the 3rd minus 2. This has a common factor of 5. 5 goes in there 5 times and in there twice. So this is 5. This is x to the 0, y to the 1st over 2. And then remember, if we have x to the 0, we can rewrite it as just 5 times 1, which is 5, y over 2. All right, we have one more to do on that. Try these, and then, as I said, I think that we'll pause the notes there. All right, so the last one I'm going to do right here. Actually, I'll do it right now. I'll get in this sheet of paper. All right, it is long though, so maybe I'll stay this direction. So it says for E, 3xy to the negative 2 all squared, 2x cubed yz, 6yz squared to the negative 1. All right, so all of this will be raised to the 2nd power. All of this, there's just a 1 right there, so no need to multiply the exponents, and this is all being multiplied by, all the exponents will be multiplied by a negative 1. So this will be 3 to the 1 times 2, x to the 1 times 2, y to the negative 2 times 2, times 2x cubed yz, times 6 to the 1 times negative 1, y to the 1 times negative 1, and z to the to the 2 times negative 1. So this is 3 to the 2nd, x to the 2nd, y to the negative 4, times 2x cubed, I'm going to put my y to the 1st and z to the 1st. This is 6 to the, times 6 to the negative 1, y to the negative 1, z to the negative 2. I'll go ahead and group all my coefficients out front. So I've got a 3 squared, a 2, and a 6 to the negative 1. My x's, I have an x to the second, an x to the third, and then my y's, I have a y to the -4, and a y to the first, and a y to the -1. And then my z's, I have a z to the first, and I have a z to the -2. All right, 3 squared, that's 9. 9 times 2 is 18. 18. 6 to the -1 is going to drop into the denominator. So 6 to the -1 is going to become 6 to the +1, but we really don't need to write that 1. I'm multiplying here, so I'll apply the addition rule. That's 2 plus 3. I'm multiplying here, so I'll go ahead and I'll apply the addition rule. -4 plus 1, and then plus -1, so -1. And then z to the 1 plus -2, which is 1 minus 2. 18 over 6 is 3. This would be x to the 5th. Y to the, that would be -4. Right? These two will just cancel out. And then z to the -1. And so finally, without negative exponents, we get 3x to the 5th over y to the +4, z to the +1. All right, I'm going to pause the notes there. I'll pick up for part 2 so that the file isn't too large. Have a great break.